Alright, this is a quick tutorial on how to read graduated cylinders. Now, if the first thing we have to do is we have to identify what the unit is. So, look down here, milliliters, milliliters, milliliters for all three of them. Okay. The next thing we're going to need to look at is I can read and say, okay, from this point right here to this point right here is 1 milliliter, and from this point right here to here is 10 milliliters, and here to here is 5 milliliters. That's the easy part. Now, what can be a little more difficult is what is the distance between those two, and the distance between these two, and the distance between these two. Okay? Now, there's one easy way to do it. What you'll do is you take the, let's take the green pen here. I take this number right here, so 2, and I got 1. So I'll go 2 minus 1 equals 1. All right? And then I count how many graduations I go. So I go 1, 2, 3, 4, 5. So it took me 5 graduations to get to the next lined one with numbers on it. So what I would do is I'd take that, divide by 5, which means I get 0.2 milliliters. Same thing here, 20 minus 10 equals 10. And same number of graduations, 1, 2, 3, 4, 5. Divide that by 5, that means each one of this space right here is 2 milliliters. Okay, this, from here there's 5, but I also have 1, 2, 3, 4, 5. 10 minus 5 equals 5. Okay, divide by 5, I get 1 milliliter. Which means these unmarked lines, these unmarked graduations, are 1 milliliter in C, 2 milliliters in B, and 0.2 milliliters in A. So now let's go ahead and do an example. If you could, I'm going to pause the video and then I'll write in these three questions. Alright, I took the liberty of erasing all the other calculations, but I still left the graduations on there. So go ahead and pause the video again and take a look at what you think these measurements are. Remember, do not forget your units. Okay, now, I know over here I'm going by 0.2. So if I go up 1, 2, 3, that means my measurement will be 3 point something. Now if I know each one's worth 0.2, that's 0.2, 0.4. Now if you look, 0.4 is just below where the meniscus is. Remember, in a graduated cylinder or any cylindrical object, there's going to be a natural curvature with water and other solutions. So you always want to measure the bottom of the meniscus. So in this case, it's 3.2, 3.4, and it's not quite 3.6. Okay, so I mean it's 3.2, 3.4, and then you have it's not even 3.5. Okay, it's not really right in the middle either. It's just below it. So it's like 3.4, probably 3.48. Okay. Now, here's the thing. When it comes to measurements, this number is a certain number. I know that that's 3. This one right here, I know that that's 4. Okay? It's this last number where we have a little degree of uncertainty, and that's going to play a big part into determining whether a measurement is accurate or not. Okay? And I will go into great detail in another video about the importance of accuracy. Okay? But in the meantime, let's go ahead and take a look at this next one. Look at B. So I know B is 20, and then this would be, so 20, 22, 24. So 26 is right here, but it looks like it's just below 26. So I would go probably 25. That's pretty certain, okay? But it's not exactly 25, because 25 is in between these two right here. So it's like 25, let's go ahead and say 25.5. Okay? Now, here, I have, this one is pretty certain, but both of these, okay, both this guy right here and this guy right here, sorry I don't have the same arrows and circles going, but these arrows are both uncertain because I don't have a nice clear graduation for them. The only graduation that I have that's clear is the 20. Okay? So, let's go ahead and I'm going to rewrite this. There, that looks a little better. But pretty much what I'm showing you is that I have two uncertain values right there, and it's just kind of, it doesn't make for a very accurate measurement. All right, lastly, we have C, which we go up to 20, 21, so there's 20, 21, 22, 23. It's not up to 24 yet, so it's going to be 23. Now, both of these are certain values. Okay, so this one is certain, and this one is certain. But I don't, it's not up to 24, and it's not exactly 23 and a half. It's like maybe 23, like, I don't know, say 23.3. Well, that is a number that I had to kind of speculate at, which means this number is an uncertain number. Now, if I was to ask you, which one of these three graduated cylinders is the most accurate, well, one thing that I would look at is, I would look at where the uncertain value is. Here, I have an uncertain value actually in the ones place. Okay, if you're uncertain in the ones place, then it's probably not that accurate of a tool. This, I'm inaccurate in the 10th place. But over here, it's actually the hundredths place. Which means the 10th place is accurate, and it is a certain number. Which means this guy right here, okay, not test tube, but graduate cylinder A, would be the more accurate of, or the most accurate of these three. Okay, so hope that helps a little bit with your reading of graduated cylinders as well as the accuracy. Oh, almost forgot. Whenever you make readings on a graduated cylinder, always put it on a flat surface and then you swoop down to eye level so you can see the meniscus. Never lift the graduated cylinder up and try to read it that way.